students. In today's class, we just discussed about the topic called properties of borazole. Okay, so in properties, we'll just discuss physical and chemical properties. So physical properties, let us see the physical properties of borazole. It is a colorless liquid with aromatic smell. As I already told you that borazole is similar with the structure of benzene. So benzene is aromatic in nature. So borazole also aromatic in nature. So it shows aromatic odor. Okay, and it is having a boiling point of 64.5 degrees centigrade. Okay, that means boiling point means what? The point where this liquid borazole converts into vapor, that point is called as a boiling point. So at 64.5 degrees centigrade, borazole is converting into vapor state. Okay, so let us see the chemical properties now. So I told you what is a chemical property. So chemical property is nothing but reaction of borazole with some new reactants to produce a desired products. Okay, so chemical properties many times utilized as applications. So let us see the first reaction with HBr or HCl. That means here borazole is reacting with hydrobromic acid or hydrochloric acid to produce a tribromoborazole or trichloroborazole. Okay, so let us see the reaction, how it proceeds. I am taking the borazole first. I am adding HCl, 3 molecules. So if you observe borazole, inside we are having three double bonds. So among boron and nitrogen is more electronegative. So it attracts electrons towards nitrogen. Okay, boron is somewhat less electronegative. Nitrogen is more electronegative because of its small size. So when it is attracting electrons towards itself, nitrogen gets a negative charge, boron gets a positive charge. So now what will happen if you take HCl, H is getting the positive charge, chlorine is getting the negative charge because chlorine is more electronegative than hydrogen. So now here nitrogen attracts a positively charged H plus ions. Boron attracts a negatively charged Cl minus ions. So you can clearly observe nitrogen is getting added with hydrogens. Boron is getting added with chlorine atoms or chlorine ions, chloride ions. So finally we are getting intermediate as hydrogen chloride derivative of borazole. That means here by reacting with hydrochloric acid we are getting this particular derivative from borazole. So we can call it as hydrogen chloride derivative of borazole. Okay, now I am heating this particular intermediate. Okay, when I am heating this particular product, we are getting this boron trichloroborazole. So when I am heating this at 50 to 100 degrees centigrade, it gets dehydrogenated. That means 3 molecules of hydrogens are removed from here. That means from where these hydrogens are removed. Let us see. Hydrogen atom from the boron and one more hydrogen atom from this nitrogen is getting liberated. So we are getting one H2 from here, and here one hydrogen atom from boron and one hydrogen atom from nitrogen. Here also one H2, and here you can observe one more hydrogen atom from boron and one more hydrogen atom from this nitrogen. So finally we are getting 3 hydrogen molecules which are liberated out. Okay, so finally we are getting the product called trichloroborazole, and here chlorine atoms are getting attached with boron, so we can call it as boron trichloroborazole. Okay, so this is the important reaction of borazole with HBr or HCl. So let us see some more chemical properties. So next reaction is a reaction with bromine. Okay, so in this reaction borazole reacts with excess of bromine to produce a tribromoborazole and HBr as a byproduct. Okay, so let us see this reaction. I am taking the borazole, I am adding 3 molecules of bromine. So when I am adding 3 molecules of bromine, here what will happen? Same, nitrogen is being electronegative, it attracts a double bond electrons towards itself. Hence we get a negative charge on nitrogen and positive charge on the bromine. Okay, so again this bromine can dissociate into Br plus and Br minus. Okay, this Br minus attacks on the bromine which is having a positive charge, and Br minus, Br plus attacks on the nitrogen which is having a negative charge. So you can see clearly. So each element in the structure gets reacted with bromine and forms a bond with the bromine. We are getting a hexabrommocyclotriborazole. Okay, so next let us remove three molecules of HBr from this structure. So I am removing hydrogen atom from the nitrogen and bromine atom from the boron. So here also I am removing this bromine and hydrogen. Here one more hydrogen and bromine. Totally I am removing three molecules of HBr and getting tribromoborazole as a product. Okay, so next reaction with water. So when this borazole is reacting with the 9 molecules of water, it produces boric acid and ammonia along with that hydrogen gas as a byproduct. So it is getting so when it is hydrolyzed, the ring is getting breakage. So the ring gets breakage and produces three main products in this structure. So and the reaction is completely balanced, you can clearly observe. So here three boron atoms are present in the structure, three boron, and hydrogens, if you observe hydrogens, here 9, here 9, 18, 18 plus 6, 24 hydrogens are there. You can also observe here 9 2s are 18, 18 and 6, 24 hydrogens. Okay, so next you have nitrogens, three nitrogen atoms. Here also you can observe three nitrogen atoms. Okay, oxygens, we are having 9 oxygens here. 9 oxygens are present in the structure. So hence the reaction is completely balanced. So when it is reacting with water, it produces a boric acid and ammonia along with hydrogen gas as a byproduct. Okay. Coming to the next reaction, that is pyrolysis or pyrolysis. Okay. So borazole undergoes pyrolysis at 340 degrees centigrade to produce two dimers. Okay, B6 and 6H10 and B5 and 5H8. So pyrolysis means heating in the absence of oxygen. So we are heating the borazole 4 molecules in the absence of oxygen at 340 degrees centigrade. It produces B6 and 6H10. Okay, B6 and 6H10, which is a dimer. Dimer means it is obtained by the combination of two molecules of borazole. Okay, so this is obtained from two molecules of borazole combined to produce this product, and one more product is formed, that is B5 and 5H8. Okay, so this is similar to biphenyl compound of the benzene, and this is similar to naphthalene. Okay, so both are the dimers which are formed from the borazole. Okay, so these are the important chemical reactions of borazole. Okay, so please practice the reactions, then you can remember easily. Okay, thank you so much for watching.